Good evening, all. So today is the continuation of the previous class. We are discussing about the past papers. Unit 1, you have to take out tutorial 3. All of you have the tutorial 3. I have discussed until 14th question in the last week class. So let's focus on the 15th question, right? Third tutorial, 15th question. I think everybody has the tutorial with you. That is 2011 question. 2011. The energy of one mole, the concept is there. The energy of one mole of photons with wavelength 305 nanometers is, they are asking about the energy. So Planck constant is given, speed of light is also given. I'm a little bit confused at the beginning of the question, right? If I read it again, the energy of one mole of photon with wavelength 305 nanometer is okay. So now we are talking about E equals h nu. So this is where we can find the energy, right? So the E is, I have clearly mentioned in the theory class, energy of one proton, one photon. H is the Planck constant. Nu is the frequency. And also we know C equals nu lambda. C is the speed of light. This is speed of light. Nu is the frequency, same frequency that we are talking about. Lambda is wavelength. Now, if we consider these two, we can combine these two equations because the question is given about a lambda also. The question is involving in a lambda as well. Now, if I take these two equations separately, E equals h nu. This is the first equation. And the second equation is C equals nu lambda. Second equation. So I can combine these two. I can substitute the values for nu because nu is not given. We have been given with lambda. So E equals h nu is C divided by lambda. That's okay to remember these equations as well. H C divided by nu. That is also okay. Then this is energy of one photon. Then energy of one mole of photon means we know mole means a number. I told you the number is the Avogadro number, right? So if we want to take the energy of one mole, then this has to be multiplied by Avogadro number. Avogadro number is Na. So I have to multiply both of these sides by Na. We have discussed these things. Na is the Avogadro number. So this ENA becomes energy of one mole of photon. Right. So energy of one mole of photon is given. That is energy of one mole of photon is need to find. Yes. Then H is given. So we have to find ENA. So Planck constant H 6.62. You have to use the given values, not the values that you know, right? Then C is 3 into 10 to the power 8 ms minus 1. Since this is an MCQ question, no need to substitute with the units as well. So if you are confident enough, that is okay. But you have to remember that all the things should be in the SI units. Then Na, that is 6.022 into 10 to the power 23. Total one divided by lambda. Lambda value is 305 nanometers. So SI unit is 305 into 10 to the power minus 9 meters. So you can do this math and get the final answer for this one. There is a little bit of calculation is here. So you have to do that one. Okay. Now the answer should be let's try to do this one a little bit. 6.602, 6.62 into 3 into 6.022 divided by 305 into, let's consider this one as 3.05. If this is 3.05, that will become 10 to the power minus 7. 10 to the power minus 7, we will take it up. Then 10 to the power 30. Then 10 to the power minus 34 into 10 to the power 38. So this is 6.662 into 2 into 3 into 6.022 divided by 305 into 10 to the power 4. So this is in joules. After doing this calculation, you can take the answer. The answer is in kilojoules. So if I do the math, like this is around, you can do something like this. You can see this is also 3, this is also 3. Right? So these two can be cancelled off. These two can be cancelled off. Then when you multiply these two, this should be somewhere around 6 into 6 means 36. So that is somewhere between 36 and 40 in between. So if you look at the answers, 302 cannot be, but 392 is the ideal candidate because 452 cannot be, 512 cannot be, 256 cannot be, because this answer should be in between 36 and 40, because 6.6 into 6 means 6 into 6 means that is around 36. 6.6 into 6 means that is around 39.6 something. So answer should be somewhere around 390 or something. So answer should be then, answer must be 392 kilojoules. So this is how you save the time. By just looking at the answers, you can take the answer of this one. So the answer should be third answer. This is 2011. If there are any questions, you can ask from me. Since I'm revising the theories and since I'm doing the calculations as well, if you need some notes, you can take the notes with me. In order to save the time, I will keep doing the questions. I will give you 1 to 2 minutes. I have given you the instructions how to do the questions. Just taking the answer is not enough. You have to show how you have taken the answer, and also if there are any theories, you have to mention them as well. So this is how you learn. Okay. If there are any questions, you can ask from me. එදා කිව්ව පණිවිඩය කට්ටිය පොඩ්ඩක් පටලගෙන දන්නේ මම කිව්වේ බ්‍රහස්පතින්දා සිකුරාදා දෙකම තියෙනවා කියලා. සිකුරාදා තියෙනවා කියලා නෙමෙයි. කට්ටිය අඩු නිසා මම මේ බැලුවේ. right? Then I will move into the next question, next one. That is our 16th question. Before the 16th question, there is a description is given. Let's try to read this question, right? I haven't done this question. Sorry, I haven't done this theory, this specific theory in the class, because I could do this one in this theory, in this question, right? Questions 16 and 17 are based on the following paragraph. Read the paragraph carefully and select the answers for the questions. This is 2012 questions. Two questions has been given based on this paragraph. When light strikes on certain metal surfaces, electrons can be ejected from it. Let's continue to do it. I will explain now. Continue to read it. I will explain this one. The energy carried by the photon in light is transferred to electrons in the metal, and if an electron acquires sufficient energy to overcome its attractive forces with the positive charge nucleus, it may escape from the surface as a photoelectron. And that's a good thing. The minimum energy required for the electron to escape varies from one metal to another. So it's something like this, Pute. Now you take a metal surface like this. So metal surface is consists of atoms. Atoms means there are protons or nucleus. Around nucleus we have electrons like this in their orbitals. Let me draw in the orbitals as well. Otherwise people will ask where are the orbitals. So they are moving in orbitals like this. There are many electrons. Now when light is struck in the surface of the metal, light is carrying energy that is in the form of E equals h nu, right? So light is having photons. The photon, one photon is having E equals h nu energy. We don't know how much of photons are coming here. Let's say ample amount of photons are coming here. Then energy will be accumulated. Energy will be absorbed by each and every electron. Let's say if one electron is coming into a certain energy, then if that energy is enough to overcome the attraction between the positive nucleus and itself, that means there are some attractions in between these two. If this attraction energy, or attraction is also a force or an energy, if this energy is equal to the energy coming from the quantum packets from the lights, then electron can overcome this attraction and move away from the neutron or the nucleus. So now energy is coming to the surface. One electron can accumulate the energy coming from each and every photon. Then if that energy is equal to the energy or attraction in between the electron and the nucleus, then energy can eject from the nucleus. Actually, we are talking about the ionization energy here, releasing an electron, right? So ionization energy, I discussed that it need to absorb energy. I have explained roughly about this one. It need to absorb energy. While releasing energy, it can't release electrons, because if you can remember, when we are explaining about the spectrums, I told you that absorption spectrum is happening while absorbing energy. So absorbing energy means it is taking in energy from outside. Then electrons can overcome the attraction between itself and the nucleus and eject from the nucleus or eject from the atom completely. Here also happening. So in this scenario as well, the energy is supplied in terms of light. How light is supplying energy in terms of the quantums. So the quantum packets is having the energy of E equals h nu. There are numerous E equals h nu packets, and they will be absorbed by the electrons, and the electron will be ejected like this. So here quantum packets are coming like this. This is the scenario. So when you place a metal in the sunlight, if the energy coming from the sunlight is enough to eject this electron or overcome this attraction, then electrons can be ejected. Okay. Then this electron is also having energy, because we know electron is also having dual particle nature. So it is also having a frequency, and it is also having a lambda, and it is also having a energy plus a velocity. Right? So you need to understand, electron is also, then after that, after ejecting, it is also showing wave particle duality nature, and it is also having a frequency, it is also having lambda, and also it is having an energy as well. Right? So this is the scenario. So this is metal surface. This is ejected electron. This is light energy. Right? Now, the concept is clear. Anyone who is not clear on this one, you can ask me questions while unmuting, or you can type in the chat window as well. I have opened the chat window as well. Then let's go to the question. This is the concept. The energy required for photoelectrons to be ejected from the surface of the barium. It is given as this is, we are talking about barium. Barium is Ba. Ba is in the second group. Just for your information, this is in the second group. Barium. We are not talking about beryllium. This is barium. Barium is a good metal. The energy required for photoelectrons to be ejected from the surface of the barium is 240 kilojoules. That means it need to absorb 240 kilojoules to eject it for the ejection. That means this total energy will be absorbed by the ejected electron. Otherwise, there is no point of saying this one. We are talking about how much of energy is absorbed or acquired by one electron to be ejected. That is 240 kilojoules. This is a very small energy, but this is a very huge energy. 240 kilojoules we are talking about, right? Per 1 mole of electron. Make per 1 mole, not 1 electron, per 1 mole of electrons. Not only one electron we are talking about ejecting 1 mole of electron. 1, 2, 3, 4, 5, 6 Avogadro number will be ejected. For that one, it is needing 240 kilojoules of energy, not only for one electron. It is clearly given. The minimum frequency of light capable of producing a photoelectron in barium. Now I told you, now this 1 mole of energy or 1 mole of electron is having this energy, right? So having said that, since this is having an energy, electrons are also showing wave particle duality. They also have a frequency because this is having this energy. Now we can find the frequency by using E equals h nu equation. But there is a problem. This E is energy of one electron or one photoelectron. Why this name is used? If this electron is ejected by using photons, those are called as photoelectrons. Right? So this is energy of one photoelectron, E equals h nu. But and also we know the energy of one mole as well. If you know the one mole of energy, you can calculate the energy of one electron, right? By dividing it by the Avogadro number. 240 is for 1 mole. For 1 electron, 240 divided by Avogadro number. Then we can substitute H and we can calculate the nu as well. So energy is 240 kilojoules. I will take it in joules then, because 6.62 is coming with joules per second into nu. So this is for 1 mole, but I need for 1 electron, this has to be divided by 6.622 022 into 10 to the power 23. This is 1 electron. So you can find nu in this way. Nu will be 240 into 10 to the power, sorry, 3 divided by 6.022 into 10 to the power 23 into 6.62 into 10 to the power minus 34. So if I do the math, this will be something like 2.4 into 10 to the power 5. Let's take the decimal places separately. 2.4 divided by 6.022 into 6.62. That is 10 to the power 5. 10 to the power 5 is 10 to the power minus 11. Yes, minus 11. 10 to the power 5, 10 to the power 11, 10 to the power 16. This is hertz per second. Kasi hadilak තියෙන්නේ 2.4 and 6. This is 0.4. Roughly අපි මේක හිතමු. This one is 39, or let's say 40. 2.4 divided by 40. So this means 3 divided by 5, roughly, or 3 divided by 50, because it is coming with 8. So this means 0.06 into 10 to the power 14 per second. Sorry, 16 per second. So this is 6 into roughly 10 to the power 14 per second, or hertz. Got that there now? 6.022 into 6.62 is roughly 40, because we have calculated same in the previous thing as well, or you can take like it is like around 39. I make a 40 kilo gatta. So 2.4 divided by 40 is 0.06, because 2.4 is also divided by 8, 40 is also divided by 8. That is now 50 divided by, so 3 divided by 50. 3 divided by 50 means 6 divided by 100. 0.06 into 16. So which means 6 into 14. So the answer should be, yeah, fourth one. Fourth one is the answer. The important point of this question is you have to understand 240 kilojoules per mole of electron, and also they're asking about the frequency, right? Any questions on this one? I think no, right? Good. So let's move to the next one. The maximum wavelength of light that can produce. Okay, wait. What is the assumption that we have made here in this question? When we are doing this question, there is an assumption that we are making in this question. The assumption here is we are talking about, now in this concept, when I am explaining, I told you that one photon may be responsible for releasing one electron, or may be responsible for releasing two electrons, or like multiple of quantums may be responsible for releasing multiple amount of electrons. But here we are talking about the energy requirement, or energy of 1 mole of electrons, photoelectrons, is 240 kilojoules. At the point that we divide this 240 by this Avogadro number, because Avogadro number means that amount of electrons that we are talking about, we are indicating that each and every electron has the same energy. Otherwise, we can't divide. If we could divide this one, because we are talking about evenly absorbed energy for each and every electron. Otherwise, we can't divide them. So that is the assumption that we are making, but practically it is not the case. Each and every electron will not be absorbing the same energy by the photoelectrons, or sorry, by the photons. So therefore, that is an assumption that we are making to simplify this question, right? So electrons, then it has a frequency. Then they're talking about the 17th question, the minimum wavelength of light that can produce this effect in barium is. Now they are talking about the wavelength. And here also we have to make an assumption after electrons are released or ejected from the atom, they are traveling at the speed of light. Now, can you remember in cathode rays, I was talking about cathode rays are traveling at 0.9 C, not C. But here it is not mentioned. Actual cathode rays are electrons, right? But here we are talking about C. There is a reason for it. Now, the C means, or 3 into 10 to the power 8 means the speed of electromagnetic waves at in a vacuum. In a vacuum. But is cathode ray a vacuum? It is closer to the vacuum. We are taking out the gas, but we are not taking out completely, right? There is some kind of pressure. Otherwise, cathode rays will not be produced. We know cathode rays are produced from the gaseous atoms remaining within the cathode ray tube. And also it has like 0.05 mmHg pressure as well. So therefore, it is not a vacuum. So since it is not a vacuum, electrons cannot traveling at c speed. That's the point. Right? But here we have to assume that electrons are traveling at a vacuum. So it is those things are not mentioned in this MCQ question. At that time there were many arguments on this one, how to do this one, because those assumptions are not mentioned, blah blah blah. But the professor said like students should have capable of assuming these things, otherwise the students cannot be considered as up to the level. So here we have to make an assumption. C equals lambda nu. Now C is 3 into 10 to the power 8 ms minus 1. Lambda what we have to find. Then nu is 6 into 10 to the power 14 per second. Into 6. So lambda is equal to 3 into 10 to the power 8 divided by 60, 10 to the power 14. So this is 0.5, 10 to the power minus 6. We can write this down as, because the answer is given in nanometers. Nanometers means 10 to the power minus 9, right? But then again, those are also tested. So we have to multiply it by 1000, this one. This should be 500 into 10 to the power minus 9. So it is, answer is 500 nanometers. So here the answer should be 17th question. The answer should be the third one. Right. මම ඔය කියපුව ඔක්කොම උඩට දාගන්න ඕනේ. ගොඩක් දේවල් කියනවා. ඒ දේවල් ටික ඔක්කොම උඩට දාගන්න ඕනේ ටක් 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 ගාලා. Okay. Then the 18th question. The number of atomic orbitals possible for which the quantum numbers n equals 3 and ml equals minus 1. So when n equals 3, let me check whether it is ml or ms. Sorry. It should be ml. Ms cannot be, no? Yeah. ml is equal to minus 1. So this is our table, right? They're asking about our table, the main table. So when n is equal to 3, L is equal to 0, L is equal to 1, and L is equal to 2. So here ml values will be 0. Here ml values will be -1, 0 and +1. Here ml values will be -1, sorry, -2, -1, 0, +1, and +2. So n minus 3 and ml -1. So there are 2 electrons which is responsible for this one. So the answer also should be second answer. There are 2 orbitals, so answer also should be the second answer. It's simply the theory. So you should know how the quantum numbers are behaving, right? Because quantum number question definitely will be there. Okay. That is 2013 question. So let's move into the 2013 19th question. Make 2013 or 19th question. 19th question. 2013, I think this is 42nd question or something, if I'm not mistaken. All emissions ended up in n equals 1 for the Balmer series in the hydrogen spectrum. For the Balmer series, n equals 1. So it's a direct theory. We know Balmer series is produced when the electrons are falling down to n equals 2. N equals 2, when electrons are falling down to n equals 2, it is forming Balmer series. When they are falling into n equals 1, it is Lyman. N equals 3, that is Paschen. N equals 4, that is Bracket. N equals 5, that is Fund. So likewise, these names and falling down principal quantum number need to be remembered. These questions are many times asked, right? In many ways. So the first answer is wrong. 19th question, first answer is wrong. First statement is wrong. Then let's go to the second statement. I explained how to do these questions, right? So the second statement is the Bohr model is used to explain the origin of the hydrogen spectrum. This is correct because Bohr model is used to, if you can remember, I have explained the energy level concept by using the Bohr theorem, because in the Bohr theorem they are saying electrons are moving around an energy level. When energy is absorbed, they are moving into the higher energy levels, and while releasing energy, it is moving into the lower energy levels. So those are some statements coming from the Bohr theorem. So hydrogen spectrum can be very easily explained by using hydrogen spectrum. So the second answer or the second statement is correct. When you are answering this one, so you write all the postulates that we have discussed about the Bohr theorem in your answer sheet. Answer script. Right? No problem. If you take some time, that's okay. Right now you have enough time, right? What you need to understand is, what you need to do is, you have to be very solid with the theories, and you have to recall and revise the things in a timely manner. ඒකයි මම ක්ලාස් එකක් දාලා තියෙන්නේ. මේ තියරිම කරනවට වඩා මේක මම මේ ක්ලාස් එක දාලා තියෙන්නේ ඔය රිවයිස් කරන්න ඔයාලත් එක්ක තනියම. right? ඔයාලත් තනියම රිවයිස් කරගන්න. Okay. So the first statement is wrong, second statement is correct. I have explained this one in the previous class, so answer should be fourth one. First equation, first statement is correct, second statement is also correct. Meanwhile, second statement is explaining the first equation, then the answer should be the first one. If both statements are correct, if second statement is independent from the first statement, then the answer should be second. Then first statement is correct, second statement is wrong, then the answer is third one. If the first statement is wrong, second statement is correct, then fourth one. If both are incorrect, answer is fifth one. So this is how you consider, how you take out the numbers or the correct choices. Right. Now let's go to the 20th question. That is 2014. If I'm not mistaken, this is 2014 36th question. Okay, D එක හදාගන්න පුතේ. D answer එක D කියන එක. Its photon has a higher energy than its photon has a higher energy than a photon of higher energy than wait. Its photon has a higher its photon has a higher energy than a photon of wavelength 100 nanometers. මේක හදාගන්න ඕන 200 nanometer wavelength photon has a 200 nanometer photon has a higher energy than a photon of radiation of wavelength 100 meters, 100 nanometers. Right? Now this is a ABCD question. First one. Sorry, let's read the question carefully. Which of the following statement is true with regard to electromagnetic radiation of wavelength 200 nanometers? Right, 200 nanometers කියන තමයි අහන්නේ. හරි. ඒතර අර B එක ඕන ඉතින් හදාගන්න ඕනෙත් නැහැ. Okay. ප්‍රශ්නේ 200 nanometer කියලා දීලා තියෙනවා. It has a higher frequency than the radiation of wavelength 400 nanometers. So we know lambda has inverse relationship with frequency. So when lambda is increases, frequency should be decreasing. So 200 nanometers means it has a lower frequency than, sorry, lower lambda than 400 nanometers. So therefore frequency here it should be increased. Here frequency should be decreased because of the inverse relationship. So the first one is correct. It has a higher frequency because lambda is lower. Lambda lower means higher frequency. So first one is correct. So A is correct. Now let's take a B. It is in the visible region of electromagnetic spectrum. Make a direct theory. So they are expecting that we can remember the wavelength of the visible region. If you can remember, I have given this in your theory note as well. Right? So usually the visible region is ranges from 400 nanometers to 700 nanometers. Roughly 750. This is the wavelength of visible region. Wavelength of visible region. අනිවාර්යයෙන් මේක මතක තියාගන්න ඕනේ. මේක දෙපාරක් අහලා තියෙනවා. Two times it has been asked. ඔයාලගේ note එකේ හරි short note එකක් හරි මොකක් හරි තැනකට මේක ගේන්න. Right? Roughly in my note there may be some small deviations. I'm talking about roughly 400 nanometers to 750 nanometers. This is needed. අනිවාර්යයෙන් මතක තියෙන්න ඕනේ visible region lambda. That's why I have given these nanometers lambda values as well in the theory note, right? So 200 nanometers is not belongs to the visible region, right? So this is not in the visible region. So B is wrong. They're talking about it is in the visible region of the electromagnetic spectrum. So that is wrong. Third one. In a vacuum, it has a higher velocity than radiation of wavelength of 400 nanometers. Actually, even though this is also a direct theory. In a vacuum, any electromagnetic wave with any frequency has a constant velocity in the vacuum. It can be gamma rays, it can be X-rays, it can be like lower frequencies like radio waves, blah, blah, blah. So any frequency in a vacuum, if it is electromagnetic wave, it has the same frequency, same velocity. The same velocity is like 3 into 10 to the power 8. So it is not changing. It's a constant, right? So therefore, C is also wrong. Why the importance of this vacuum is, Uday, if it is not a vacuum, we know each and every rays are showing different characteristics. For an example, gamma rays are not ionizing the gas or ionizing the atmosphere that it is traveling. But when it comes to the radio waves can be undergoing different distortions. You know, when it is raining, your DTV, dialogue TV signals are dropping, right? They are vanishing. They are, it has interference. So which means it is undergoing some kind of ionization. So it is not traveling at the speed of light, right? So if it is not a vacuum, there may be some changes in the velocities in the electromagnetic spectrum, right? But if it is a vacuum, velocity is constant, right? Then D, its photon has a higher energy than a photon of radiation of wavelength. So we know E equals h nu, and we can say E equals hc divided by lambda, right? So when C and h are constant, we can say E is inversely proportional to lambda, right? So lower the lambda, higher the energy. So basically 200 nanometer is having a lower energy and 100 nanometer is having higher energy. So as a result of that, D is having wrong impression. So D is also wrong for this one. So only A is correct, B is wrong, C is wrong, D is wrong. So answer should be the fifth one. Answer should be the fifth one. Right? So these kind of small things, maybe you have not done in the theory class. We have not done these things. Everything we have not done in the theory class. But by using the theories that we have used, you should be able to derive these kind of things as well. Okay. Right. Now into the next question. 21st question. 21st question is 2015. Yeah, 2015 question. That is also ABCD question. Good. Which of the following statement is true for an electron that has the quantum numbers n equals 3 and ml equals 2? Okay, minus 2. Okay. The electron is in the third main energy level. That is obvious. A is correct. B. The electron is d orbital. That is also correct because ml means minus 2 means L should be 2. Because L cannot be 3 for n equals 3. So when n equals 3, L can be 0, 1 and 2. So ml is minus 2 means it should come from ml equals 2. So ml equals 2 means this is d. So electron is in d orbital. That is also correct. The electron is in p orbital. That is wrong. If it is in the p orbital, it cannot have minus 2 because p orbital means L equals 1, right? So L equals 1 have minus 1, 0 and plus 1 for ml values. So C is wrong. Right. The electron must have a spin quantum number ms equals plus half. The electron must have a spin quantum number ms equals plus half. Must කියන පදය නිසා we can't say that this is correct because when ml equals minus 2 and n equals 3, ms can be minus half and plus half. right? So D is also wrong. So the answer is first one and second one is correct. So the answer should be the first one. Because ABCD questions, A and B correct, then first one, B and C correct, second one, C and D correct, third one, A and D, fourth one. Any other option, answer is or choice is fifth one. Right. So for the 21st or 2015 question, answer is first one, right? So let's go to the 22nd question. That is 2017. There was a question on 2016, but not on these type of questions. Like it's a different question. It was included in somewhere else in the institute. Let's read this question. A lamp produces 6 joules of energy per second in the blue region, 470 nanometer of the visible light. For how long should be the lamp lit to generate 1 into 10 to the power 20 photons? This is a good question actually, right? So 2017 question, right? So lamp, they are talking about a lamp, right? A lamp 6.0 joules per second. They're talking about per second, it is generating this much of energy, right? So a lamp produces 6 joules of energy per second in the region of 470 nanometers visible range, visible light. For how long should be the lamp should lit generate 1 into 10 to the power 20 photons? Okay. Now, um, now we can simply say E equals h nu, right? This is energy for one photon, right? So let's calculate the energy of one photon, right? So the energy of one photon, try to understand my algorithm. So this is energy of one photon. Let's say E is equal to H means 6.62 into 10 to the power minus 34. Nu is C divided by lambda. I have explained this one. So that is 3 into 10 to the power 8. Total one divided by the lambda value. Lambda value is here 470 into 10 to the power minus 9. Always should be in the SI units, otherwise your answer will be wrong. So this is energy of one photon, right? And also that is saying, now this is having some kind of energy, right? Joules. For 1 second, it is generating 6 joules. So we can calculate for 1 second how many photons it will be generating, right? So we know energy of one photon, and per second how much of energy is generated. So you can say how much of seconds that will be taken to sorry, how many photons that will be generated in 1 second, because energy per 1 second is given, right? So photons generated in 1 second, because we know energy of one photon and energy generated in 1 second is also known. So this will be 6 joules divided by 6.62 into 10 to the power 34 into 3 into 10 to the power 8. Total one should be divided by 470 into 10 to the power minus 9. අපිට මේක තව හදන්න පුළුවන් 6 into 470 into 10 to the power minus 9, 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8. So this is photons generated in 1 second. And we have been asked how many seconds is needed for 1 into 10 to the power 20 photons, right? So therefore, seconds needed for 1 into 10 to the power 20 photons. So this value is photons generated in 1 second, right? So how many is needed to generate 1 into 10 to the power 20 photons is you have to divide this value by 1 into 10 to the power 23. So this will be 1 into 10 to the power 20. This should be divided by 6 into 470 into 10 to the power minus 9. Total one divided by 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8. 1 into 10 to the power 20 into 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8. Total one divided by 6 into 470 into 10 to the power minus 9. මුතු ගණන් දෙනවා මගේ පේපර් වලත් මේ වගේ ගණන් ඇතිනේ. Now අපි උඩින් ගත්තේ මොකද? දැන් පැහැදිලි කරනවා නම් energy of one photon we have calculated. Then for 1 second, how much of photons will be generated we have calculated, because energy for 1 second is given. If you know energy of one photon, we know how much of photons will be generated in 1 second. Then we have been given how much of seconds is needed for 1 into 10 to the power 20. That means it should be divided by 1 into 10 to the power 20, because we know how much of photons will be generated in 1 second. So the answer for this one, 1 into 6.62 into 3 divided by 6 into 470, 20, this is 17, 7 plus 7, minus 9 උඩට ගියාට පස්සේ plus 8 එක එකතු වෙලා 17 වෙනවා. 17 plus 20, 37. 37 into minus 34, 10 to the power 3. So this one you have to calculate. You can take 618.19 divided by 0, 2, and 42. 42 and 24, 28 into 10 to the power 3. So you can take this one as 19.86 divided by 2.820. This is something like 20 divided by 3, roughly. 20 divided by 3 means that is somewhere around 6.667, no? 6.667. So closest value is 7.1. So answer should be 7.1 seconds. I have taken some approximations for this one. So this is very good question. This is 2017 12th question. Right? You should be able to do questions like this. Otherwise, there may be, that's why we need to do these kind of past paper questions. Right? So the answer should be the second one. It is given. Now, ඔයාලට දැන් තේරෙන්න ඕන මම මේ ගණන් එකක්වත් ලඝු පොතමන් එළියට ගන්න නැහැ. හරිද? ඔයාලා අතට දාගෙන මේ ලඝු පොත අරගෙන හදන්නත් පුළුවන්. No issue, no problem. But this level of calculation tricks has to be used. Otherwise, you will ran out of time, right? 23rd question, 2019, right? Let's quickly go through this one. Considering the following statements, 1 and 2, the energy absorbed or released by atoms is quantized. Quantized, okay. Small particles under appropriate conditions show wave properties. The two scientists who proposed the theories as given by statement 1 and 2 respectively are Dirac theories. So 23rd question, that is 2019 question. The energy absorbed or released by atom is quantized. Actually, this is quantum theory. Quantum theory is given by Max Planck. Max Planck. Small particle under appropriate conditions of wave properties, that is de Broglie, right? Louis de Broglie. So these should be the answers. So our answer is the second one. Because Louis de Broglie and Albert Einstein, first answer, there is no matching there. Because there is no relationship between Louis de Broglie and the quantization. Third one, Max Planck is correct. Ernest Rutherford, no, cannot be. Ernest Rutherford is coming from the proton and the earlier stage of wave particle duality. Ernest Rutherford is not there. Niels Bohr and Louis de Broglie. Actually, Buddha, even though that we are not learning about Niels Bohr in the quantum physics, Niels Bohr also a pioneer in the quantum physics. So at that time, 2019, because Niels Bohr also has done some theories on the quantumization of quantum physics. The marks are given for this answer as well. මේක theory එකක් විදිහට ගන්න නැහැ. හැබැයි ඇත්තම ගත්තොත් එහෙම Niels Bohr is also involved in the quantum physics or quantumization mechanics, quantumization theory. Not only the Max Planck, they are one group, right? So fifth answer is also makes no sense. Louis de Broglie and Max Planck, that cannot be, because Louis de Broglie is not involving in any quantum story, right? So answer they have given fourth one and second one both, but අපි දන්න theory second one එක තමයි හරිය. හරිද? Then 24th question, 2020. Consider the following discoveries made with regard to the atomic structure. Atomic structure. Positive rays inside cathode ray tube. Okay. Radioactivity by certain types of nuclei. The two scientists, two scientists who discovered the above stated 1 and 2 are respectively. Positive rays, that is found by Eugene Goldstein. Goldstein, right? And radioactivity, Becquerel, Henry Becquerel. There is no argument. The answer is the fifth one. Positive rays inside the cathode ray tube, Goldstein. There is no argument for this one. J.J. Thomson has done some experiments on the positive rays, but it has been found by Goldstein, Eugene Goldstein. And the radioactivity, there is none other than Henry Becquerel. So the answer should be the fifth one. Those are direct theories. Short notes, these kind of things should be there. Right. Let's move into the 2020, the next question. 25th question. The de Broglie wavelength of a neutron traveling at a velocity of v is nu. If the kinetic energy E equals mv squared of this neutron is increased 4 times, the new de Broglie wavelength would be. මේ වගේ ප්‍රශ්නයක් මේ මගේ පේපර් එකකට මම හිතන්නේ මම දුන්නා. හරිද? So මේ ගානේ මට කියලා දෙන්න දේවල් ටිකකුත් තියෙනවා. Right? So therefore ගොඩක් කට්ටිය අද මේක නැති නිසා මම දැනට class එක මම නවත්තන්නම්. ගොඩක් රැ වෙලා තියෙන නිසා. So let me stop the class from here for today. The recording I will stop.